One of the most important design patterns in games is object pooling.
This pool?
No, not that pool.
How about this one?
No, that's not what I mean. I want object pooling for games. Let me explain. Have you ever seen a game get stuck and stop being fluid and the game becomes unresponsive? This happens because things get created and destroyed on demand. For example, if you need a car in the game will create this car, then you crash it and destroy the car with an explosion. Then everything that belongs to that car goes to a trash bin, and once the computer accumulates enough trash or sometimes passes, the garbage collector will come and clean up all the mess. Now imagine you need a new car and the game creates it in its factory, again from scratch. This takes a lot of time and resources to build a new one. So instead of building again from scratch, build them ahead of time and store them until needed. Once used, instead of throwing to the trash again, recycle them. For example, you can build all those cars and pretty much all the cars look the same, just different colors, shapes, specs, and so on, but those things can be pooled. Another example is bullets in your game, or particles, enemies, anything that can be reused can be pooled. So this is object pooling, the idea of recycling the stuff you need in your game so you don't need to trash things and lose time when playing. So how do you implement it? We are going to explore 3 ways to do it. Let's see now the very basic design pattern. Just create 2 lists, one of items that are in use and one for items that are in stock or not in use yet. Whenever you need one new object for your game, you pick up one from the free list and move it to the use list, so you can easily do this in C#. And once the item needs to be destroyed, move it back to the free list of items. This is quite fast to do, performs quite well. Now let's see another similar way to do it. Instead of using 2 lists, we are going to use 1 list and 1 queue. A queue behaves very similar to a list, but there are minor differences. The first thing is that a queue is a first in, first out kind of list, and it cannot be randomly accessed. You can only pick the first item in the queue, but it's faster than a list. In the case of a list, when you pick up the first item, the list needs to update every other item after the item is removed to update the position of all the items in the list. So it can be very inefficient and slow if you have a very large number of objects in the list. If the number of items is small, then there is not much difference. But since we are going to 1,000 of items, a queue will perform a lot better. How much better? Let's see a few tests I did. The results may surprise you. The first one is with 2 lists with 50,000 items and recycle over 100 times per frame. It took 285.71 milliseconds on average. Very slow, but usually you will not need to recycle 50,000 items per frame. Let's see now what a usual number can be, like 500. So it took around 2.8 milliseconds on average to create 500 items and recycle them over 100 times. It's not that much time, at least 2.8 milliseconds, but thinking that if you're targeting 60 frames per second, 2.8 is quite a lot. Now let's see what a queue and a list will do. 50,000 items created and recycled over 100 times gave an average of 1.33 milliseconds. That's less than half the lowest number from 2 lists. And then I tested 500 items, same as 2 lists, and recycle over 100 times. I got 0 milliseconds on average. Yes, 0. So it was practically free. As you can see, using 1 list and 1 queue was extremely fast. So it makes more sense to use 1 list and 1 queue or 1 list and 1 stack. Stack will give you the same number as a queue since both behave the same way. Now let's look at a third way to do it. You can use something called stack. A stack is very similar to a queue and it will perform pretty much the same as a queue. So either one should work the same. Now the first version we can call it Mark 1 version. I wrote 2 lists and wrote the code that managed the content of both lists. For every new pool, I had to copy paste the same code everywhere. Second version, Mark 2, I make a generic list manager so I do not have to copy paste too much code, but still I had to create the 2 lists and write a code that will call the generic code to manage the list. This was in my second game, Loot Rat. Mark 3 version is ready now and it will be used in my third game. This time 100% of the list management is inside a generic class, so I only need to declare 1 variable. That will be the bullet pool or anything that needs a pool. Then add this to a list of pools and everything else is managed by that list. So I do not have to write any additional code. Mark 3 version saves me a lot of effort and pool management. If you are interested, you can download the code in the link below, so you will be able to copy paste the classes I have created, so you can pool like me. And that's it for today. First of all, thank you so much to the new subscribers, and we completed last week's quest. Woohoo! This is another time for celebration. Please, if you have not subscribed, help me reach my next milestone. And that's it for today, but before we finish, let's see what is this week's quest. If you like this video, click like and subscribe and the notification bell so you don't miss the next episode. See you next week.